Another example, another very striking one, is a topic of considerable discussion among neuroscientists and philosophers and psychologists today, is the issue of what's known as conscious will. Many of us think that when we make a decision as to what to do, even banal decisions, whether or not to have another sip of coffee or to pick up a pen or to close your laptop or to open your cell phone, many of us feel that those decisions are things that are subject to my conscious awareness. I now decide to open up that laptop. I now decide to turn off the phone, and lo and behold, the phone turns off. But remember that just because you've got correlation, that does not produce causality. After all, there's a high correlation between, for example, waking up with your shoes on and waking up with a headache. But going to bed with your shoes on or waking up with them probably doesn't cause you to have a headache. There's probably an underlying cause of your having gone to bed with your shoes on and waking up with a headache as well. I'll let you speculate about what that underlying cause is. But correlation does not produce causality. So too, the fact there's a correlation between my decision to open up my cell phone, my decision to close my laptop, my decision to wave to that friend across the street, well, they, generally speaking, are followed by the relevant actions, but that does not prove causality either. And in fact, some neuroscientists have been arguing that the idea that there is a causal relationship between my decision to do something and my doing it is in fact illusory. This is a controversial topic, and it's more controversial than some of the other examples we've discussed thus far, but I want you to be aware of it, partly because it's fascinating and it provides an interesting challenge to much of our views about our own selves as agents in our lives. According to recent research, there's a course of time that goes from the activation in your brain that occurs before an action takes place and taking place of an action, somewhere like 500 to 600 milliseconds. At the beginning of that process is what's known as the brain readiness potential. Let that be, for example, negative 600 milliseconds. There's a sort of spiking in neural activity when an action is about to ensue. That's the brain RP, or readiness potential. And then you've got the action, the pushing of a button on a phone, the raising of a hand, the whistling, whatever it is. Now, Libet, a neuroscientist, and other researchers have done experiments in which they put subjects in a room in which they had access to a very, very large and easy to read, very precise timepiece. And they said, I want you to take notice of the time when you decide, that is consciously will, to, for example, lift your hand or wiggle your finger. And then keep that in mind and let me know later on what the time was when you did that. So here goes. Boom. I keep track of the clock. I know what time it is. The results of the experiment suggest that the brain readiness potential spikes at negative 600 milliseconds, but the conscious volition, that time that I take notice of when I decide to, for example, wiggle my finger, happens at something more like negative 300 milliseconds. So the brain readiness potential, the spiking happens here. The conscious willing, the decision to act, happens here, and then you've got the action. And that way of thinking about the times course, the suggestion is that the, so to speak, train left the station back here. And the conscious decision to do something happened after the train left the station. And if that's right, it raises the question, precisely how did my conscious decision have an impact on my action? It looks as if the action was already underway, or at least the neural process that was leading up to the action was already underway before I made a conscious decision to do anything. It's as if, think back to the days of the steam locomotives. Steam locomotives have steam coming out of the smokestack. The steam doesn't make the locomotive go. What makes the locomotive go is the burning of the coal in the engine. But the steam is, so to speak, an epiphenomenon. It happens as a result of the burning of the coal, but it doesn't make the engine go. So maybe your conscious decision, your conscious will, is just like the steam. And the brain readiness potential is more like the actual burning of the coal in the engine itself. What makes the engine move is something that happened well before you made a decision. If that picture is right, then your attempt to introspect on your own decision-making is interesting enough, but it's not clear that decision has very much causal power in determining you to do what you take yourself to do. Now, as I've said, this is a controversial set of experiments. It's not clear that it decisively shows that conscious will is an illusion. Many psychologists and neuroscientists do want to conclude that, but that's a controversial conclusion, something that I'll be asking you to speculate on in some of the study questions that'll be associated with today's lecture.